So we're here today on the Severn Valley Railway. As the name suggests, the railway runs along the Severn Valley. Now, for the last 150 years since the railway was built, the water, when it rains, runs down the hill towards the river, as you'd expect. And about 6 metres down, there's what's called a slip plane. The water causes two surfaces to slide over each other. If you imagine two sheets of A4 paper, you can push them across each other. And that's been going on for the last 150 years. So for the last 150 years, civil engineers from time to time have to take some remedial action to fix the track, which is slowly sliding into the River Severn. And what we've been doing today is using geopolymers to fix the problem once and for all. So if you imagine these two sheets of paper that are sliding over each other, what we're effectively doing is applying staples between the sheets of paper. We are injecting geopolymer into the slip plane, fixing the slip plane and stopping it sliding.
The track already has some settlement sensors or tilt sensors. What these sensors do basically measure the level of tilt that the track is experiencing on a daily basis. So these sensors have been installed for almost a period of 2 years, and they've been recording data since then. And from the data, we've actually learned that the track has been losing tilt by approximately 9 mil every year. And what we're hoping that following the injections, we're going to monitor these sensors, the outcome of these sensors, and see if there's a change in the degradation level as a result of the injection. We've also done some ground probing to see the before and after results of the injections, which shown some significant improvement, and that's already been done. We tested our treatment in a virtual software or in a virtual environment in the software to give us an outcome and see if the treatment is going to work. And after we kind of got good results from that and we managed to optimize the design, we've started finalizing the design and, as you can see here, installing it into the ground.
So one of the real challenges that you have with injecting geopolymer is understanding what the problem is, what the engineering problem is, and particularly what's the engineering design solution. Because if you get it wrong, we could have built a dam here and the water's now coming down off the hill, and we've just constructed a geopolymer dam. Guess what? That railway is going into that river even faster than it's ever gone in before. So the design is really, really crucial. You'll notice, if you can see behind me, and you'll notice from where the injection tubes are, the spacing is really important, the depth is really important. What we want to do is stiffen the embankment, stop the embankment from moving, but leave sufficient path for the water to continue to flow down to the river. This solution works really, really well in short intervals. If you only had 6 hours of track access, you can put the probes in, put the geopolymer in, clear everything up, and be off-site very, very quickly. So you can actually work in short duration possessions every midweek night, working along the track, fixing the problem so that you don't disrupt the passenger service, and that's really, really important about this solution. We can do it in short intervals, no passenger disruption, and when we've finished, you get a much better track and a much better passenger service.